Hi guys, we are doing chapter 6, problem 4. I am Pirojaki Marcy and I have Star Maze with me. The problem states, on January 1st, 2011, you are considering an investment that will pay $12,500 a year for 5 years beginning on December 31st, 2013. If you require a 9% return on your investment, how much are you willing to pay for this investment? To analyze this problem, we look at beginning on December 31st, 2013, and this indicates a deferred annuity because there is no cash flow in the first period. Then, how much are you willing to pay for this investment? This indicates that we are looking for present value. Return on your investment is 9%, and that gives us the interest rate of 9%. $12,500 a year for 5 years. That indicates equal payments of $12,500 for 5 years. Here we must determine the N for each payment. Now there are two approaches to this problem. The first approach, to determine the value of each period and add the values for a combined total. The second approach is determine the present value of the annuity using a two-step approach. Approach 1. Determining the N value for each payment period. So as you see, in 2013 was the very first payment of $12,500, and there are no payments for 2011 and 2012. The first period, the payment is $12,500, and it is on the third year. So we are going to take a look at the table 2, present value of a dollar, and it is at 9%. N equals 3 would be 0.77218. We'll multiply that by 12,500 and we'll get a present value of $9,652.25. We'll do the second one. The second period payment was $12,500. Now looking at the table, we are going with N equals 4. 9% gives us 0.70843, and the present value after multiplying it by 12,500 will be $8,855.38. We'll do the same thing with the third period. N equals 5. 9%, by looking at the table, it will give us 0.64993, and multiplying that by 12,500 will give us $8,124.13. Same goes with the fourth period. Looking at the table, N equals 6 and 9%. Multiply that by 12,500, the payments. And the fifth period, 12,500, looking at the table, at N equals 7 and 9% interest, and it will give us 6,837.88. And after combining the values, we'll come up with $40,923.02. And that concludes approach number 1. Now, to look at approach number 2, first need to calculate the present value of the annuity at the beginning of the payment period, which is December 31st, 2013. Present value annuity equals present value times present value annuity of $1. Interest rate of 9%, and N equals 5. present value start at annuity payments, which is $12,500 on December 31st of 2013. It will be 12,500 times 0.388965, and that will give us $48,620.63. We then have to calculate the present value of the present value annuity at January 1st, 2011. And that is the future amount times the present value of $1, and it would be interest of 9%, and N would be equals to 48,620.63 times 0.84168, and that will give us $40,923.02. Regardless of what approach you use, the present value of the annuity is the same. The present value is $40,923.02. The second approach is a lot more useful when the N equals 20 or a longer period. Using this approach, the calculation would be less time consuming.